Friends, you are welcome back to the discussion of the language Lisp. In the first part, we discussed a number of issues about the programming language Lisp. We were discussing evaluation of valid expressions in the language Lisp. I further elaborate what is meant by evaluation of an expression in a language. For example, we say write the word run, which is read as run. But just by speaking out run or by writing run, the act of running is not done. Somebody, after reading the three-letter word run, actually starts the process in which the steps are changed and the movement takes place of a particular person. The action associated with the run word is the meaning of the word. Similarly, if you write on a paper add 4 to 5, just reading this sentence or command add 4 to 5 will not yield the answer 9. However, if the process through which the answer 9 is returned is the meaning of the sentence add 4 to 5. Write a recipe for good food, say for making dosa. Just by reading the recipe, we don't get a dosa. Line by line somebody reads and acts according to whatever is written over there. Just through the actions, appropriate actions of reading the commands to prepare dosa, we get actually a dosa. What all through this I mean to say is that meaning is what is denoted on the paper. Once again, add 4 to 5. If written on paper and not acted upon, will never yield 9. The process through which we get 9 is the meaning of the sentence or command add 4 to 5. So once again, evaluation means associating the intended meaning. I hope it is clear what is meant by evaluation of an expression. So first of all, when in a program or any expression which is written and given to the environment of a programming language, the meaning is attempted to be found out. And the meaning is possible only when whatever is written has a valid expression. For example, if man eats food, which makes sense, if it is written over there, we'll get some meaning out of it. However, food eats man does not create any sense in everyday context, and therefore our system does not work in that on that particular statement, illegal statement, that food eats man. Similar is the situation in the case of programming language environments also. When something which carries a meaning is encountered by the environment, it acts appropriately. However, if something like food eats man is encountered by the environment of the language, then it says error, something like that. So first of all, it must be clear to all of us that whenever a program is given to a machine to be executed, the purpose is to find out the value of the expression expressed as a program. And if there are some errors, that is, there are some situations or there are some part of expressions which don't carry any meaning to the language, then it returns error. So whenever we talk of evaluation once again I mean to say is associating something in everyday context. For example, if car is written C-A-R. Now in everyday context it is a four-wheeled vehicle with a particular color and various mechanisms inbuilt which carry us from one place to other. And bring a car inside will have a meaning which asks us to move a car from outside to inside. However, writing BRINGACAR inside will not do anything until unless somebody takes action after reading the statement. So we must be very clear that there is something like expression and there is something like an associated meaning with that expression. So what is the purpose? When we write expressions, we actually write the expressions. It is not the computer system which writes the expressions, but those expressions are intended to be associated some meaning with. When we say add 4 to 5, we just write it. How the computer returns 9. Generally we don't write such an expression for adding 4 or 5. But we do give commands to add thousands of numbers, each of thousands of digits. Because the computer is very fast in addition and all that. However, we write the solution in terms of which the computer has to act upon, because we know what steps are required to be followed in order to get the solution. The computer is used only for the purpose because it can act on our commands much faster than we can act on those commands. So the whole story is about what? The whole story is about writing expressions which are generally written by human beings, and those expressions are written in such a way that the computer acts upon them to finally yield the intended solution. So the evaluation comes into picture that for each expression which we write, the computer is to find out the associative meaning. Add 4 to 5, it actually activates those processes by which the sum of 4 and 5, that is 9, is returned. So with this much explanation, now we'll come to evaluation of valid expression in the language list. Please look, we say, so the very first thing that I said, that whenever there is a horizontal arrow pointing towards the right and you enter anything, and if that thing that which you have entered has a legal meaning, then various actions are generated in the computer system which is called evaluation. So the very first thing which the evaluation should do is about the numbers. If you write a sequence of digits, possibly containing dot and E in between, then according to our own definition it represents a number. And the value of this is that number itself. So this is one thing which must be clear, that when a number is represented or entered by a computer system, the number itself is its value. I hope it is very clear. Next, we'll talk about quoted expressions. What is a quoted expression? Friends, sometimes we write the word car. Now once I utter or write CAR or I utter car, we have a picture of a vehicle with 4 wheels, etc., etc. However, in some cases I like to say something. The word car has 3 letters. Here I don't have at all the picture of the car in my mind. Rather, I have the word car about which I am saying that it has 3 letters. Now the two are different. In the first case, we have the whole picture of the car with four wheels which can take us from one place to the other. In the second case, we have just the intention of a particular word which has three letters. Now, how to differentiate the representation of the two? In the case of everyday language, sometimes we write quotes between, around the word. If we want to say the word car has three letters, we generally either quote or we make it italic or we do, but it is not written in a normal way. If we write in a normal way, we will be having something like that. A car can take a person from one place to the other. A car has three letters, has different connotation for the uses of car here. However, how to tell the difference to the computer systems? Different languages have different mechanisms by which the word car and the entity car are differentiated. In the language Lisp, what we do, that if I want to say something like this, the word car has three letters. In what we'll do, we'll write a single quote before CAR. And the computer system will understand, now we don't intend to discuss this particular word in terms of a vehicle having four wheels. Rather, we need to find out the letters or the shape of letters, etc., etc. So the symbol quote is put before the expression, where the expression is intended to stand for itself. So in the case of the second example of evaluation, that whenever a quote followed by any expression, then the meaning of that is taken that expression without quotes. I hope it is very clear that when you are writing quote car, and we write quote car has three letters, then after evaluation the word CAR will come. But if you have not put quote, then this CAR will mean for a vehicle of four wheels. So I have clarified that sometimes a word is intended to represent something else, sometimes a word is intended to represent itself. How to differentiate between the two uses? In the case of language Lisp, it is done by using the symbol quote before the word. So, if you want to just write the letter or word color, C-O-L-O-U-R, you don't want to tell whether it is red, whether it is blue, etc. You just want to talk about the letter color, about the word color, which has 6 letters. I don't want to talk of color of a person or a vehicle or anything. Only I want to discuss the word color which has 6 letters. I want to say the word color has 6 letters. So what I'll do, I'll put a code in order that the computer system understands it as a word of 6 letters instead of something which our eyes can differentiate between. I hope it is clear. So whenever some expression is intended to stand for itself, the symbol quote is placed before it in order to show that the meaning of this whole expression is the expression itself. Next, evaluating symbol, friends. Now I want to say, I want to use car as a car, vehicle of 4 wheels. Bring inside a car, or create the picture of a car. I want to tell the computer system, create a picture of a car. and I don't want the computer system to tell me how many letters are there in the word car. Then it should be the word car should be used without quotes. The letter quote, the symbol quote which is put before the word or expression should not be used if I want to draw the picture of a car, or I want the picture of a car to be drawn by the computer system. So here what happens? That with each word there is an associated meaning, and that meaning is given to the word at some stage or other for the computer system. How we have started associating four-wheeled object as a car? Through our frequent uses among us ourselves. But the computer is not habitual of interactions like that. Therefore, it has to be told clearly in the form of pictures or through other ways, through the definition that a car has four wheels, it has a steering wheel, it has a number of seats, it has a particular color and all that. So either this definition must be given or some pictorial representation must be there, and if it is not quoted, then that picture or that definition should be prompted in order to find out the value of that particular object, in this particular case the car. So what is the mechanism? Once again I repeat that for each word, the man, the dog, or etc., anything, we get the meaning through our very frequent social interactions, that dog is associated with an animal of four legs, a tail, etc., which barks or can bark at least. But the computer system has to be told explicitly at some stage that this object is meant by this word dog. Or there may be a pictorial representation of the dog, and then that picture should be prompted once the word dog is written on the screen without quotes. So the meanings have to be given to the system at some stage or other explicitly by someone. And only those meanings are prompted or used by the computer systems when the commands or expressions are encountered by it. This is a very important point which we must understand very clearly. Now, for example, when you are writing color and you are talking the color of your shirt, which happens to be white. So here you are not interested, tell me the color of my shirt, we ask the computer system. Now here we are not at all interested in the computer telling us that the word color has 6 letters, not at all. At some stage we must have told the computer system that the shirt, my shirt, is of white color. And we expect the answer white to be reflected by the computer system when it is asked what is the color of my shirt. So how it is to be done, as I mentioned earlier also, it has to be fed to the computer system at some stage. My shirt value is white. It must have been mentioned. So this mechanism of associating values with the words which are expected to occur in our interaction with the computer system must have been told in advance. So while looking here, for example, color is meant to be of something red. So at some stage the value of this color for that particular something should have been associated, I emphasize, sometimes earlier as red. And if it has been done, then once you write against the prompt, which is a arrow pointing towards the right, if you write COLOUR without a quote, then the computer system will reflect the value red, provided this red has been associated sometimes with color. Now we will discuss a number of other functions which are inbuilt in the computer system, whose values have been already defined to the computer system. That is, the meaning of that have been already written in terms of the programs which are executed in order to find out the value which are inbuilt. So let us take some of the examples of the inbuilt functions. Inbuilt functions means you have not to tell the computer system, the computer system has already been told about that in terms of programs. So let us look, as I mentioned in the beginning, that the operators like plus, minus, multiplication, division, etc. must be written before all the operands in expressions which are intended to be executed by Lisp environment. That is, in Lisp, the operand plus or cross must precede the numbers 3, 4, 8, 11, minus 2. It is not generally so. For example, if we are writing in C language, then generally in order to find out the sum of these numbers, we write 3 plus 4 plus 8 plus 11 plus minus 2. But in the case of Lisp, the first we write the operator, that is plus, and then we write whatever are to be plussed, whatever are to be added. You can see one advantage of this. The good advantage of this is that you have to write the symbol plus only once. However, in the case of infix operators, you may have to write it a number of times. But anyway, because the Lisp environment will not take 3 plus 4 as operation plus, it will take it as just a symbol, as I mentioned in the very beginning itself. But if it finds plus in the very beginning, then those processes which are meant for addition of numbers are activated automatically, and one by one the numbers are read and their values are added, and ultimately the final value comes. So in this particular case, the value which is associated with plus 3, 4, 8, 11, minus 2 is obtained as follows. First 3 is added to 4 to get the number 7, and then the 7 is added to 8 to get the number 15, and the 15 then is added to the next number 11 to get 26, and finally 26 is added to minus 2 to get the final value 24. I hope you are clear how the inbuilt mechanisms or the Lisp environment works in order to find out the value associated with plus 3, 4, 8, 11, minus 2. Friends, look at the two expressions written horizontally. One is plus 3, 4, 8, 11, minus 2 bounded on both sides by parentheses, and the other is a single number 24. 24 is obtained not directly from plus 3, 4, 8, 11, minus 2. Rather, 24 has been obtained by a sequence of processes in which at intermediate stages, first the number 7 came as a result of addition of 3 and 4, then the number 15 came as a result of addition of 7 and 8, then the number 26 came as a result of addition of 15 and 11, and so on and so forth. So the meaning is something which is related to the expression, but it is not the expression itself. Similarly, sometimes instead of cross you may write plus, P-L-U-S. The inbuilt mechanisms in the system will take this as cross. This also is taken as a initiation of a process which will ultimately find out the value of the sum of 3, 4, 8, 11, etc. Similarly, minus 1355. What is this expression standing for? This expression stands for that the Lisp environment should activate those components which find out the difference of two numbers 13 and 55, and ultimately return minus 42. Similarly, difference. Difference is same as minus 13. Similarly, we can find out the values of other expressions. Again, for example, we are having star 2, 3, 4. Star represents the multiplication operation, and in this case we get the value 24. I again emphasize that we must differentiate between an expression and its value. An expression is something which is written on the paper or spoken from the mouth. It may be a vocal expression, it may be a written expression. But that expression is actually intended for something different, generally different in the real world. When we say BOI, generally we don't mean a 3-letter word, but we mean a biological system, which is male, etc., etc. So the 3-letter word BOY is associated in the real world with a biological system, and it is not a particular system but a generic system, in the sense that all the boys in the world, any one of them fits with this. I hope you understand what is the difference between an expression and its intended meaning. So again we discuss the multiplication operation. Sometimes it is represented by star, it may be also represented by TIMES. Similarly, the next one is the division. So slash, the backslash followed by the numbers, then the backslash represents the quotient. That is, divide the first number by the second number, whatever is the quotient, you take that as the value of this expression. Next, we have some other arithmetic operators. For example, the absolute value function is there. So we know the absolute value of any number is either the number or its negative, depending upon the given number is positive or negative. If the number is negative, then its positive values. So ABS is the symbol which is used in Lisp in order to find out the value of absolute. EXPT is exponents. EXPT 3, 2. What does this stand for? 3 raised to power 2 in our senses. That is, EXPT followed by 3 followed by 2 actually understands for those actions which are required to find out the square of 3, and ultimately the value 9, which is found through those processes. Whole of this is represented to the computer system by parenthesis, in which EXPT is followed by 3 followed by 2. And similarly many other arithmetic expressions which we know very well. For example, max 8, 11, 9, 7. This max tells the computer system that you compare one by one in pairs the numbers written on its in the given expression and find out the maximum of those and return that as value. For example, this expression, pair of parentheses including max 8, 11, 9, 7. It stands for a sequence of process, a process which first of all picks up the two numbers 8 and 11, finds their maximum. The maximum of these two numbers happens to be 11. Then it takes the next number and compares with the previously returned maximum, that is 11 and 9. Again 11 happens to be the maximum of the two numbers. Then it takes again the next number, that is 7, and it compares with the new number 7, the earlier returned maximum 11. This whole process, the word process, is represented by this expression in which there are two parentheses for containing max 8, 11, 9 and 7. The final answer 11 is not just the meaning associated with the expression, rather this whole process. However, we are interested in the final value. Therefore, sometimes we forget the whole process by which we have got the final value. But as a student of computer science, we must be very careful that any expression here may be representing an object or entity, or may be representing a whole process. Here max 8, 11, 9, 7 just does not represent only 11, but it represents the whole of the process through which we have obtained the 11. We must be very clear about this. Similarly, there are other expressions which are known to us in our everyday context. I need not discuss them, but one or two I may just mention by the way. For example, truncate 14, 4. It says divide 14 by 4. And whatever is the remainder, forget it. However, if you are interested in the remainder, then you forget the quotient and just write REM 14 4. Similarly, the word round is there. In that case, if you are given a number which is not an integer, for example, you are given 14.3, you are interested in its only the integral part, and therefore round 14.3 returns the value 14. But again I emphasize that the pair of parentheses including the word round and 14.3 is not just 14, but it is the whole process through which you get the number 14. Float 14, sometimes we are interested in converting a integer into a real number. Then instead of rounding, we do the opposite operation. We write float 14. That is, the argument of float is always an integer, and the value 14.0 is returned. Evaluating a function. Friends, so far we have discussed some of the inbuilt arithmetic operations like plus, multiplications, round, float, etc. But I told you that the major advantage of language Lisp is not numerical computation. It is non-numeric computations. So, in addition to whatever we have discussed, plus, minus, multiplication, etc., we must discuss how to execute non-numeric functions, how those are first of all represented, how their value is found by the computer system in a Lisp environment. So we discuss all these things. That is, first of all, how various functions, as I mentioned earlier in the very beginning, that in Lisp all these solutions are written in terms of definition of functions. And then those functions definitions are executed by the Lisp environment. By this time you must be very clear what is meant by execution. By execution we mean that when something is written over there, we find out the associated values in the real world. When a car has 4 wheels, here the car actually is something automobile, and that automobile has to be associated once the word car is encountered by the computer system. So meaning is something in the real world. Generally it may be abstract also, but generally it is something which we can sense, about which we can talk, etc. So evaluation always tries to find out the thing associated generally in the real world with the word which is written over there. Now I come to the definition of function, how it is defined to the Lisp environment. This is one thing, and secondly how it is executed. Executed means how we find out the associated thing in the world. So first let us come to the definition, how we define, how we express as a sequence of characters to the Lisp environment, and how the Lisp environment finally acts upon that. So first we come to the definition of functions in the Lisp, which we give in the sequence of characters. Let us look. A list of the form this. So first of all, a function must be expressed as a list, and by definition of a list is expressed when a pair of parentheses is used at boundaries. You can find the red part. There is the first symbol which is left parenthesis, and there is the last symbol which is a right parenthesis. If the first symbol is a left parenthesis and the last symbol is a right parenthesis, then the whole of it, whatever may be included inside, is a list by definition of LIST, list. Now we are in this particular case discussing how a function is defined. For example, we want to find out the sum of any two given numbers. Or we more generally say we are interested in finding out the sum of squares of two given numbers. And we are not interested in finding out the sum of squares of two particular numbers. There is an application in which we will be required to find out the sum of squares of a large number of pairs of numbers. First of all, may be required to find out the sum of the squares of number 3 and 4. Then after sometimes 8 and 13. Then after sometimes it may be 8 and 24. Now if we are going to use the sum of squares very frequently, instead of using the expression x square plus y square very frequently, we define a function. We say that whenever x is something and y is something, just that function does, you need not do anything else. That is, the computer system will automatically find out the sum of the squares if you have defined a function in advance. Let us call such a function as sum sq, sum-sq. So how to describe to the Lisp environment so that it accepts it and acts upon it in appropriate way, that whenever a pair of numbers is given to it, that is, for example, 3 and 4 are given to it, then it returns 25, that is 3 square plus 4 square. But such a function has to be defined in advance. Now, what is the appropriate format in which such a function is defined is being discussed here. So we say, first of all, we'll give the name of the function. For example, just now I said sum-sq may be used as the name of the function which will find out the sum of the squares of two given numbers. But every function acts on its parameters. As in the case of sum-sq, we require two parameters, number 1 and number 2. If you are required to find out the cube of a number, here you will require just one parameter. However, if you are to find out the sum of three squares, three numbers, you are required to give three numbers x1, x2, x3. So depending upon the activity which you have in your mind, you will be defining a function which may have appropriate number of parameters. In the case of finding out square, you just need 2. You just need 1. Find out the square of 5. Find out the square of 18. You never say find out the square of 14, 18. You never say like that. This means the number of arguments, number of parameters which are required for the function finding square is just 1. However, in the case of finding out whether a particular number is between the other two numbers x, y, z, if we are always interested in finding out whether y lies between x and z, whether it is true or not, so this function between always requires three parameters x, y, z, and if it is say x is 3, y is 7 and z is 11, it will return the value true. That is 7 lies between 3 and 11. However, if the value 2, we are given 3 to 11. We are required to find out between, followed by 3, followed by 2, followed by 11, which stands for the fact whether the computer is required to find out whether the number 2 lies between 3 and 11, and in this particular case the computer system will say no. So what I mean to say through these examples is that depending upon the task under consideration, we define a function, and depending upon again the nature of the task, the number of arguments or number of parameters required by the function may be varying. Sometimes it may be just one parameter, sometimes it may be two parameters, sometimes it may be three parameters, or maybe more also. So I hope you are very clear that once we have given the name of the function, it must be followed by appropriate number of parameters. And then we give the definition how we are going to find out the value intended to be found through the function whose name is given as function name. If we are interested in finding out the sum of the squares of two numbers, what may be the process? First you find out the square of first number, then you find out the square of second number, then you find out the sum of the two squares so found. So all this has to be given in detail to the in the form of instructions or in the form of expressions to the computer system. So when this definition is executed by the computer system, the intended meaning or object is returned by the computer system. I hope it is clear. So we will take an example in order to explain the definition. For example, in the case the expression entered is a list, and a list is indicated by a pair of parentheses bounding the other things, star followed by 4 followed by 11. What would happen in this particular case? As I mentioned in the beginning, that the operator has to be mentioned in the very beginning. So the Lisp environment first of all activates the multiplication machine, a machine which or a component of the computer system which is activated for multiplication of numbers. It reads the first number 4, it reads the second number 11, and then activates those processors by which the product of these two numbers is obtained. So ultimately 44 is returned. So if this is the story about the functions which are inbuilt. However, in the case when our purpose is not served by the inbuilt functions, we define new functions. How those are executed is also similar to the inbuilt functions. For example, if we look at the expression, again a list which is to the right of the arrow pointing towards the right. It is a list in view of the fact that whatever is written to the right of the arrow is bounded by a left parenthesis and a right parenthesis. So it is a list. What the computer system will do? The computer system will read the first symbol after the left parenthesis, which happens to be a cross, and a cross is interpreted by the Lisp environment as the operation of addition. It will try to find out the sum, and sum of what? It will first of all find out the sum of the first expression, which again happens to be a sublist. And what is that sublist? Star x3. Here x is a symbol, and the value of x must have been associated earlier in order to for this expression to be legal. And suppose that we have already associated the value 2 with x, then in that case the value 2 is associated with x, star is applied, we get 6. So friends, briefly we have discussed some of the salient features of the language Lisp. I hope, however, just by listening and reading a programming language, it can't be learned. You have to write programs in order to actually learn it. Thank you.